Right, this video is going to look at several examples that are going to have you verify equations. So this is a little different than simplifying in that you have an end game, you have a final answer that you're working towards, and you're going to choose one side of the equation to manipulate, and the other side of the equation you're going to leave as is and make the other side match, which will make your verification. So you want to choose the side that's the busiest, the one that has the most going on, and that's the one that you want to manipulate. Sometimes that's a little easier to choose than others, but I want you to think about this as two separate sides of an equation, and you will not move anything from one side to the other. So you don't cross the equal sign, you leave one side as is, and you'll manipulate just one side using identities, using formulas, relationships that are true with the trig functions, and you will not like divide both sides by cosine, and you can't subtract one to the other side to make them both 0. So you're only going to manipulate one side, and in the end, for this particular problem, we should have that 1 equals 1, which is a true statement. So for this problem, there's a couple ways you could attack this problem, but the way that I'm going to start this problem is I'm going to distribute the cosine through, and cosine squared plus cosine squared times tangent. Okay, I know in my relationships with trig functions that tangent is sine over cosine, so I can rewrite tangent squared as sine squared over cosine squared. I'm multiplying that by cosine squared. Just write everything else down here. So because it's like cosine squared over 1, I can divide and cancel my cosine squareds. So I'm left with cosine squared of theta plus sine squared of theta. And that is Pythagorean identity, where cosine squared plus sine squared equals 1. And I have that 1 equals 1, so I have identified, or I have verified this equation. So we're done. I do want to point out for this particular problem that I could have taken this and instead of the distribution, I could have simply identified, again, this is sort of an or. A lot of things can be solved in two different ways, but for this one, I could have identified that 1 plus tangent squared is actually the identity for secant squared of theta. And then if I multiply that times cosine squared, secant of theta is really 1 over cosine, so secant squared is 1 over cosine squared. And if I multiply that times cosine squared, again, I have the cosines cancel, because it's one's in the numerator, one's in the denominator, they're being multiplied, and I'm left with 1. And again, 1 equals 1, so the equation has been verified. So two different ways to approach that problem, both are correct. It's just whichever formula you pull and try to think about. All right, next problem. We have sine squared minus 1 over cosine equals negative cosine of x. So the sine squared minus 1, sine squared appears in the identity function. Their identity, sine squared plus cosine squared is 1. Sine squared appears in a double angle formula, but the double angle formula won't really help us here. So for this numerator, I'm going to use the fact that cosine squared plus sine squared equals 1. And I'm going to write cosine squared as 1 minus sine squared. So I want you to notice that's almost what we have in the numerator. But their subtraction and the order of the subtraction is flipped. And we've seen this before. If the subtraction order is flipped, you can rewrite one in terms of the other if we factor out a negative. So like make that negative of negative 1 plus sine squared. That would rearrange our terms to be sine squared minus 1. And that negative that we pulled out, I could give to the other side, like divide or multiply both sides by negative 1. And I'll have negative cosine squared is the quantity sine squared minus 1. So that's what I can replace my numerator with, is negative cosine squared over cosine of x. And again, we're verifying, so don't touch the right side. Don't multiply both sides by cosine or anything like that. So my numerator is cosine squared, which is like cosine times cosine, and that allows me to divide and simplify, cancel one of those, and I'm just left with a negative cosine of x in the numerator, and that is what I was trying to get to verify. So we have verified this equation. Okay. Next example. We have sine of x times tangent of x equals 1 minus cosine squared over the cosine of x. So this one, I think the busiest one is going to be the right side, and I can make the right side look like the left side. Otherwise, I would be making a product look like a difference in a fraction, and I think that's just a little more complicated. So I'm going to manipulate the right side, and 1 minus the quantity of cosine squared is just like cosine squared of x, and the Pythagorean identity that said sine squared plus cosine squared equals 1 can be rewritten as sine squared equals 1 minus cosine squared. So that's what I'll replace this numerator with, so that I get sine squared of x over cosine of x. Now I can't cancel anything, but I will note that sine squared of x is just like writing sine of x times sine of x. And because I have a single numerator, I could split that. I could split one of these signs off and make it sine x times sine x over cosine x. Because technically that would be the same thing, right? Put sine over 1, break them apart. It's multiplication, we're allowed to do that. I don't have to give the denominator to both of them because it's not addition or subtraction. So this is not plus or minus. So I can split in that manner. And then sine over cosine, I could pull and make tangent, and that would multiply sine of x times tangent of x, which is what we were trying to verify for our problem. So those are verified. Okay. Next one has secant x minus secant x times sine squared x equals cosine. The left side is the busy one, so I'm going to try to verify that the left side equals cosine of x. So I don't have a secant squared where I could replace with a tangent, not that I would want to. I have a sine squared, but the only thing I could do is rewrite that in terms of cosine. And so for right now, I'm just going to take and identify the fact that I have two separate terms, both of which have a secant of x in common. So I'm going to start by factoring out secant of x, and I'm left with 1 minus sine squared of x. The next thing I'll note is that 1 minus sine squared is a different form of the Pythagorean identity where, again, cosine squared plus sine squared equals 1. So if I do 1 minus sine squared, I'll get that that's really cosine squared. So here I'm going to replace the 1 minus sine squared with a cosine squared of x times secant. The next thing I'll notice is, well, secant is the reciprocal of cosine. So if I rewrote secant of x as 1 over cosine of x and then multiply that times cosine squared, again, it's multiplication, there's no addition or subtraction. Think of cosine squared over 1. There's 2 cosines multiplied up top, there's 1 cosine on the bottom. I can cancel one of those up top with the one on the bottom, and I'm just left with cosine of x, which is what we were trying to verify with our equation. So verified. Equation verified. Okay. Another example here is cosine of theta over 1 minus sine of theta minus tangent of theta equals 1 over cosine of theta. The left side is the busiest, so I'm going to try to make 1 over cosine is also secant. So that could have been shown here to make it equal secant, but this one represents it as 1 over cosine. So we're just going to leave it like that. And so we are manipulating left side. So I have a subtraction that involves a fraction, and while my tangent of theta doesn't have a denominator, everything else is in terms of sines and cosines. So I don't have any squares, so I don't pull any of those formulas. So I'm just going to use the fact that tangent could be written as sine over cosine. Sine theta over cosine of theta. And then I have cosine of theta over 1 minus the sine of theta. So now I have subtraction of two fractions with just sines and cosines, nothing else. There's no square, there's no tangent. So now I'm going to do multiply and give them a common denominator. So on the left fraction, I'll multiply times cosine of theta to the numerator and the denominator. And on the right side, I'll multiply by 1 minus the sine of theta over 1 minus the sine of theta. Okay, so the top, see, this becomes cosine squared over cosine of theta times 1 minus sine of theta minus, okay, so I want to keep these separate to point out this is a subtraction of a fraction, and that fraction is going to have a quantity. So I'm going to go ahead and distribute that and identify that that's really sine of theta minus sine squared of theta over cosine of theta times 1 minus sine. And then note that I'm subtracting that entire quantity. So I'll have to subtract, I'll have cosine square of theta if I go subtract across my numerator. And I'll subtract sine theta. And I'll also have to subtract the negative sine squared. So that'll really do plus sine squared theta over cosine theta times 1 minus the sine of theta. Okay, so again, watching that subtraction of a quantity is key here. So be very careful when you subtract in the fraction numerators when there's a quantity. You have to make sure you subtract each term correctly. Next thing I'll note in my numerator to clean that up is I have a cosine squared plus a sine squared. Cosine squared plus sine squared is 1. So I have 1 minus sine theta in my numerator. And then I have cosine times 1 minus sine theta in my denominator. So this is a good example of where don't multiply out and distribute in the denominator until you have cleaned up the numerator, because you'll see for this problem we have the quantity 1 minus sine theta in both the numerator and the denominator, and you can cancel those. Quantity for quantity. You can't cancel like the 1 with the 1, the sine with the sine, but the quantity of 1 minus sine theta will cancel numerator and denominator, and you're left with 1 over the cosine of theta, which is what we were trying to get verified for our equation. So we're good. We verified. All right. Next question has us do 1 minus cosine of t over sine of t equals cosecant minus cotangent. The fact that the left portion has a fraction, that's the one that I'm going to manipulate, and I'm going to leave the right side. And again, I'm going to manipulate the left side. So I notice the right side has cosecant, cotangent, and the left side has cosines and sines. And so I'm going to end up using the relationship between those for the trig relationships. I can't really replace anything yet, but I am going to note that I have a single item in the denominator. So I can split up my fraction and do it 1 over sine t minus cosine t over sine t, which I know is backwards a lot of times when we do fraction work. So if I do that, 1 over sine is cosecant, and cosine over sine is cotangent. And now that's what we needed it to equal. Okay? The other direction, just to show you that there's, had you chosen the other way, if you had 1 minus cosine of t over sine t, if you wanted to manipulate the right side, certainly could have. I don't know for this one if one is better than the other, but if I rewrite cosecant, that's 1 over sine. If I rewrite cotangent, that's cosine over sine. And I have a common denominator, and if I subtract across the top, I get 1 minus cosine over sine, which is what you were trying to verify on the left. So this is one of those ones where I don't really know that one was easier than the other, but you could have certainly gone either direction. But again, whichever one you choose, do not touch the other side of the equation. Leave it and try to make the other side equal. So again, either direction for that one. All right, for this one we have cosecant squared of theta over cotangent of theta equals cosecant of theta times secant of theta. So I'm going to manipulate the left side only because it has the square and I feel like it's slightly more complicated. Plus cosecant times secant, that would just be 1 over sine times 1 over cosine. I can't really do anything with that. So I'm just going to leave the right side, and I'm going to manipulate the left. So there is an identity for cosecant. It's 1 plus cotangent. But I don't really think if you do that, the fact that it has a plus in it is going to create a whole lot of extra headache to try to get to our final verification, because there's no plus in the right side. So I don't think substituting cosecant squared with that identity is the way to go. So like the previous example, or one that we've seen, I'm going to break apart the fact that there's 2 cosecants and I have a cosecant in my right side. I'm going to split the fact that cosecant squared is cosecant times cosecant over cotangent, and I'm just going to sort of put cotangent with one of them. So I'll have cosecant theta, so I'm halfway there, times cosecant over cotangent. And then that's what I need to clean up. So cosecant is 1 over sine, and cotangent is cosine over sine. So I have fraction divided by fraction. So the way that that would clean up is I would have 1 over sine and divided by cosine over sine. When you divide by a fraction, the cleanup for that was multiply and then do the reciprocal of the second fraction. So if you see, that will allow me, I'll have 1 over sine times sine over cosine, and I can cancel my sine quantities. So I'll have 1 over cosine times cosecant, and 1 over cosine is secant. So I have cosecant of theta times secant of theta, which is what we were trying to verify, and we have. So you have to sort of like, again, there wasn't really anything to substitute to begin with. The fact that I had 2 cosecants up top squared, I just broke them apart and then broke the fraction apart, which you can do because it's multiplication. Put like cosecant over 1. So verified. All right, last one has us looking at the sine of x plus cosine of x over the sine of x minus cosine minus sine. Okay, so agreed, the left side is the one that's more complicated. It has a fraction, it has subtraction, and we're going to try to work through this to make it equal secant times cosecant. So what I need to do to the left side is I need to create common denominator, which I do not have. You could do that. I'm not sure how the top would clean up, but actually I think because since the right side is secant and cosecant, which those are the reciprocals of cosine and sine, and I just have single items, I might try to split this up first and write sine x, kind of going backwards from a common denominator, but I can simplify. So if I put sine over sine plus cosine over sine minus, so we're subtracting each of these, so minus cosine over cosine plus sine over cosine. All of those clean up very nice without having to get fraction denominator mess. So sine over sine is 1. Cosine over sine is cotangent. Cosine over cosine is minus 1. And sine over cosine is tangent. So we have cotangent plus tangent, and we need that to be secant times cosecant. So it still looks like we're going to have to do some denominator stuff, or some fraction, because cotangent is cosine over sine, and tangent is sine over cosine. So yeah, I think we're back. We just sort of cleaned up the top a little bit. Didn't really clean up the top. I guess sort of did. So we're still going to have to give a common denominator. We can do that here. Cosine of x times cosine of x. Right side gets multiplied times sine. The top is cosine squared plus sine squared over cosine of x times sine of x. Cosine squared plus sine squared is 1. We have 1 over cosine of x times sine of x. and it's a product in the bottom, you can split those as to 1 over cosine times 1 over sine, and that gives us our secant times cosecant that we needed to verify. Not sure that was the quickest way to do that. In fact, I may redo this. I don't think I have another page. Yeah, I may copy this just to see how that worked out. Copy. Had another page. Let's paste that guy back. So if I do that, instead of splitting them first, let's just say we kept a common denominator. So I'll multiply sine x to the top. Nope, cosine, not sine. Apologies. So I'll do cosine of x to the right fraction, and then I'll do sine x to the, sine x to the right fraction, cosine to the left fraction. So my left fraction is cosine times sine plus cosine squared. And then my right quantity, if I distribute that sine to both of those, would be minus cosine times sine, and then it'll end up being plus sine squared, because I'll do sine times sine, but when I distribute that subtraction through to that negative, that's going to create a plus on the end. And that's all over cosine times sine. I don't know that this was any quicker, but it is an alternate way to do this. So I have some cancellation. I have 2 terms of cosine sine, 1 plus 1 minus, so those are gone. I have cosine squared plus sine squared in the numerator, so that's 1. So 1 over cosine of x times sine of x. We're back to where we were for the first method. 1 over cosine is secant, 1 over sine is cosecant. So if you want to think about those as being the multiplication of those 2 forms, 1 over cosine is secant of x, 1 over sine is cosecant of x, and we have verified the one that we needed to. So again, I don't know that one is better in your brain than the other, but either way we still had to combine fractions with common denominators. So one way made a more complicated numerator, the other way split everything apart. Again, your choice for that. There's 2 different ways you could attack that, but either way we verified the equation.